Hello everybody. In this video we'll be going over one of the sections in chapter 6 of our text entitled Chemical Composition. Hello everybody. In this video we're going to be talking about percent composition. This is going to be a shorter video on a topic that seems maybe a little confusing and sometimes people could struggle on it a little bit. But the reason why it's ultimately a shorter video is because it's really something that we already covered in the last video. The percent composition is a value that we can multiply by to figure out the mass of a constituent element when we know the mass of a compound. And you might remember that in that video I said that we needed to go through the moles in order to get from that mass of a compound to the mass of its constituent element. And technically, that's still true. Basically, what we're doing with percent composition is we're taking all that math, that intermediate math, and we're just thinking about it in a different way. The percent composition is going to contain all of that math, only we're going to change it a bit so that... cursor ran off of the mouse pad. We're going to change it a bit in just the way that we have it set up in the formula and stuff. And we're going to define this new value called the percent composition. But ultimately, I just want you to keep in mind that this is the exact same thing that we've already done. So let's get into it a little bit. The percent composition of each element in a compound by mass is the percent composition. It can be determined in two ways. We can determine it from the formula of the compound, like we did in the last video, but we can also determine it using experimental data sometimes, something that we call mass analysis of a compound, which is really where this idea of percent composition really came from, is that we were doing these experiments a long time ago and we saw that we could really use them to make these sort of conversions. Sometimes you will find that the percentages that you're given are not always going to equal to 100%, and I just put this in here. And this is due to rounding, and I just put this in here because sometimes students get really hung up on that, and you really shouldn't when you see these kind of problems. You just kind of got to roll with it. So by definition, a percentage is the part that we have divided by the whole times 100%. In the context of percent composition for compounds, the percentage is going to be the mass of any one of the particular elements that we're interested in, divided by the mass of 1 mole of that compound. Okay? And then we're going to multiply that by 100%. So let's take a look at a problem here and see what we're going to do. So we're being asked to find the mass percentage of chlorine in C2CL4F2. So we're given just a formula in this case. And we're asked to find the percent of chlorine by mass. So we know the definition of percent mass, but we still need to figure out our solution map. And this is where I hope you guys can see the connection to what we were doing before. So our mass percent chlorine is going to be 4, because we know that there's 4 moles of chlorine for every 1 mole of C2CL4 times its molar mass, right? And this is some of the math that we did before, divided by the molar mass of 1 whole unit of C2CL4F2, which is ultimately what we would get if we just took the last 3 conversion factors and the previous problems and multiplied them together. So first we figure out our mass of chlorine. We know that we're going to have 4 of them, 4 moles of the chlorine times its molar mass. We go to the periodic table. We see that the atomic mass of chlorine is 35.45, so we know that it's 35.45 grams per mole. We have 4 of them. So we know that we have 141.8 grams for every mole of chlorine. And then we need to figure out the molar mass of the whole molecule. So we go and look up the carbon and the chlorine and the fluorine. And we multiply them by each of its subscripts up here. And we see that one molecule of C2Cl4F2 weighs 203.8 grams per mole. Now, we know that only a portion of this whole is chlorine, so we know that this value should be less than this one, and it is, and that makes sense, so we're happy with that. So now we know that mass percentage is going to be this mass of just the chlorine divided by this mass of the whole. We'll multiply that by 100%, and we get 69.58%. If we think about our little check, we see that this percentage is less than 100, which it should be because, again, chlorine's only a part of it. And chlorine is much heavier than the other atoms. All right, so chlorine is at 35 versus carbon at 12, fluorine at 19. And there's 4 of those, and there's only, 2 here and 2 here. So it makes sense that it's going to be the bulk of the mass. So one of the nice things that we can do with the mass percentage, other than just calculate what it is use this as a conversion factor. And this is where I was talking about how we can go from the mass of a compound to the mass of one of its constituent elements. So the mass percent tells you the mass of a constituent element in 100 grams of the compound. This 100 is coming from the fact that we're representing it as a percent, right? And there's 100%. Okay, so the fact that NaCl is 39% sodium by mass means that in 100 grams of sodium chloride, there are 39 grams of sodium. So anytime you see a mass percentage like 39, what I want you to think about is this fact right here. Okay, that there's 100 grams of or 39 grams of sodium for every 100 grams of sodium chloride. And then you'll see that you can use that to make conversion factors just like we've been doing before. Okay, so you can have 39 grams of sodium for every 100 grams of sodium chloride, or you could reverse it. And this is going to allow you to go from the mass of sodium chloride to the mass of sodium, or from the mass of sodium to the mass of sodium chloride that you're going to need.